Hey guys, good to see you again. To recap, we've gone over image representation, convolution, pooling, and dense layers. Now it's time to bring everything together by training a model. Let's get to our notebook. We have a dense model with 85,000 trainable parameters. We can see that we have trained it for 5 epochs, using default parameters on the fashion MNIST dataset, and we have an accuracy of about 98.5%. Let's take a look at our convolutional model. This model has 93,000 trainable parameters. Once we compile and train, we can see that we have an accuracy of about 99%. This is for a small data set. So let's go to another notebook and look at a larger data set. In this notebook, we train a model to categorize cats and dogs. We'll need to download the data set. It's available from the Microsoft website as a 700 megabyte archive. After extracting the archive, place this notebook into the folder. Go ahead and import TensorFlow and all the modules listed in the file. We run the ls command to see what is in the same folder as our notebook. The doc file comes inside of the zip file along with a readme. There's also a pet images folder. We've defined some constants in our notebook. We have height and width, which we'll use to resize our images because they come in varying sizes. But we need them all to be the same size because of working in batches. We've got a list of labels, which is the 2 categories we have for our data. We're dealing with color images, so our number of channels is 3. Batch size is set to 32. Our training data is contained in pet images. This contains 2 folders, cat and dog. Each folder has images with names, from 0 to 12,500. First, we create variables that hold the path to the image files, as well as the class that each image belongs to. We'll reserve some of our data for validation and testing. We make use of a loop to create the paths and append to our list variables. We then create data frames from our list, which we could store and inspect. Let's go ahead and work with just 20 examples. To train on all of our data, we would simply fetch all 11,000. Let's run a sanity check by looking at one file. The code on the screen does just that. We make use of a tf.io.read file and specify the first file name in our test data frame, and then print that out. Our output is a tensor of bytes. We need to convert this. To do that, we make use of tf.image.decode JPEG. Afterwards, we have a familiar looking tensor. We can then go ahead and look at our image. We need to repeat this process for every single image. So, we'll go ahead and define functions to do all of that. Our first function will handle decoding and resizing images, as well as normalization. Then we have a second function, which will take a path to an image, read in the image, and then run pre-processing on it. The code on line 21 will create a dataset from tensor slices. We pass in our list of file names. We'll use the map function to convert our list of the file names into images. The autotune constant lets us perform this operation in parallel. We do the same thing to our labels, but we don't need to map the labels. Because the 2 datasets are the same size, we can zip them up. Next, we need to shuffle our dataset. Notice that we create a buffer size that is 1,000 times our batch size. So we shuffle, repeat, and then prefetch so that our input pipeline doesn't become a bottleneck during training. We can now proceed to build our model. Our model summary shows that we have about 20 million parameters. This is because our images are larger. We then compile and train our model. Our dataset is iterative, and we could specify the number of epochs we would like to train for, and the number of steps per epoch. If you're working with all the data, set steps per epoch to 11,000. This will result in training time of about an hour, if you're working with CPU. If training on GPU, it'll be much faster. Congratulations on making it this far! Let's look at our assignment for this section. For your assignment, you're going to need to download some files. In the folder where you have the notebooks, there's a folder called Assignments. In that folder, there are 3 CSV files, and the URLs to images on the internet that you'll need to download. We've conveniently put each class of objects into a separate file so that there are 3 musical instruments that you need to classify, and the URL to the training data for each class in a file. So just like what we did with cats and dogs, you're going to need to download those images. You can automate the downloads. We've done that in an earlier video. And once you're done, go ahead and train a CNN. Best of luck with the assignment. And I'll see you in the next section, where we discuss sequence models.